continue our next section for Calculus 2, 7.3. This section we will calculate the volume using the shell method. So for the shell method, you can do either the vertical axis of revolution or horizontal axis of revolution, depend on your function, whichever will make it easy for you. Let's take a look at the vertical axis of revolution. So the graph will rotate around the x-axis or the y-axis. I'm trying to find my circle here. Yeah, around the y-axis. So you would have the bar or the strip that parallel to the y-axis, and the thickness of the rectangle is delta x, and this is the graph or the function. To find the volume is equal to 2 pi average radius times height times thickness. So 2 pi is 2 pi, and integral from A to B. The average radius is the distance from the strip to the y-axis, we call P of x. And the height is the height of the strip or the rectangle. It will be different at different points. For example, here is a little bit shorter, longer, and the longest will be over here. The thickness is the thickness of the rectangle, which is remain the same, is delta x. So the formula is 2 pi and integral from A to B, P of x, H of x, and D of x. For the horizontal axis of revolution, is similar idea. Then the graph will rotate around the x-axis, and the strip will be horizontal, parallel to the x-axis. The formula is the same. Volume is equal to 2 pi average radius times height times thickness. 2 pi, the integral from C to D. Average radius is the distance from the strip to the x-axis, so P of y. And the height is the height of the strip. As you can see from here to here is the short and getting longer, longest, and longest will be over here. So the height of the strip, H of y. And the thickness is remain the same, which is delta y or dy. Now let's take a look at example. Find the volume of the solid formed by revolving the region bound by x minus x to the cube and x-axis. X is greater than or equal to 0, less than or equal to 1 about the y-axis. So I have a graph here. This graph represents the function y equal to x minus x to the cube. And the x is between 0, greater than or equal to 0, less than or equal to 1. And it's rotate around the y-axis. So the rectangle will be parallel to the y-axis. And the formula that we have is V is equal to 2 pi and integral from A to B, P of x, H of x, dx. So this is two-dimensional. Now let's take a look at three-dimensional because they want you to calculate the volume. So this is the two-dimensional as I graphed to you from the previous page. Now we're gonna turn to the three-dimensional and rotate around the x-axis. So the graph will rotate around, around the y-axis. So as you can see, it's moving toward the y-axis. Then it's gonna form shape as it's rotate. So it's rotate to second quadrant now. Now it's gonna complete the 2 pi. Then this will be the shape after it's rotate around the y-axis. Now the part they want you to find is the volume. As you can see, the shaded area here is not part of the volume. The volume is the non-shaded area here, from here to here. So let's see if I can turn it so you can see better. Here we go. That's gonna be the shape, the volume that we are looking for. Okay, similar to look like a bow. Yes. All right, so that's the shape of it. Now let's go back to our calculation. Now we have this formula, so I'm going to substitute all the variable here. So 2 is 2 pi, and integral from a to b. My a is 0, my b is 1. So an integral from 0 to 1. Again, p of x is the average radius because it's rotated around the y-axis. So it's the distance from the rectangle to the y-axis, and we call it p of x. So it's basically it's the x. The distance here is x because it's on the x-axis. So I'm going to use x here times the height. So the height here is the height of the rectangle. It changed at this spot is at this point is going to be from the x-axis to the graph, and x-axis to the graph, and so on, and the graph changing. So it's going to be x minus x to the cube. So the distance from the x-axis to the graph, and the graph, the function is x minus x to the cube. The thickness is delta x. We can use dx. Right, so let's substitute more, simplify some more. So I'm going to have 2 pi, an integral from 0 to 1, distribute the x in. So I'm going to have x squared minus x to the 4th dx. So we're going to take an integral of this. So it's 2 pi. Your upper bound and lower bound is 0 to 1. So I'm going to have x to the cube over 3 minus x to the 5th over 5. And my integral is from 0 to 1. Let's finish our calculation. If I substitute the 1, I'm going to have 1/3 minus 1/5. And if I substitute 0 for x, it's going to be minus 0. Right? So we're going to have 2 pi, and LCM is 15. So it's going to be 5 minus 3, which is 2 over 15. So the answer is going to be 4 pi, because I have 2 over 15. 2 times 2 is 4 over 15. So that would be the area of the volume, I'm sorry, not the area, the volume of the solid formed by revolving the region bound by the x minus x to the cube. And again, we're using the Chow method.